Example 2. A balloon is rising straight up and is tracked by a rangefinder 500 feet from the liftoff point. At the moment, it is at an angle of pi over 4. The angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that moment? So what this question is asking for is, we have a balloon, so we have a rangefinder, and if you don't know what a rangefinder is, it's just a fancy camera. So here's our rangefinder. There's our rangefinder. And then we have our balloon, which is over here. There's our balloon, and it's going up into the air. And it's increasing at a rate of, the angle between the rangefinder and the balloon is increasing at a rate of 0.14 radians per minute. Well, we know that it's 500 feet from the liftoff point. So if I were to draw a triangle, like that, this distance right here is 500 feet, and this distance is increasing. So we're going to call that h. And we know that this is the angle between the rangefinder and the balloon. We'll call that theta. Now let me show you exactly what I'm talking about in this problem. This is what it looks like if right here is my rangefinder, where coordinate A is my rangefinder, and right here is my balloon. This purple angle right here is the angle that's created in between them. You can see how it increases and decreases as the balloon rises. So the balloon starts at the ground and then increases slowly like this. So the height of the balloon is changing, and the angle between the rangefinder, which is at point A, and the balloon is also increasing. So we want to know how fast is the balloon rising right here at when it's pi over 4, which is 45 degrees. So we want to know how fast is the balloon going up right at this particular second. So it's going up, it's going up. How fast is it going at that particular second? So what we need to do is we need to identify our variables. So we know that this value right here of 500 feet, this is fixed. This does not change. This is going to be something that does not change in our equation. Theta, however, this is going to change at a rate of d theta over dt. This is the rate of the change of theta with respect to time, and this is going to be dh dt, the change in height with respect to time. So let's pull out any pertinent information we have. Well, we know that it's 500 feet. That's our fixed distance. We know that it's at an angle of pi over 4. So when theta is pi over 4, and what else do we know? It's increasing at a rate of 0.14 radians. So this means that d theta dt is 0.14. Okay? So we always want to relate the rates before plugging in numbers. So relate the rates before plugging in numbers. So what we need is a formula to relate an angle and two sides of a triangle. So how do you relate an angle and two sides of the triangle? Well, I know that tangent of theta is equal to opposite over adjacent. And the reason I can do this is because I have a right angle right here between the ground and where the balloon takes off. So let's just start plugging in what we know. Well, we know that tangent of theta is going to be equal to h over 500. Do a little simplifying here. You can get 500 tangent of theta equals h. And the whole goal here is to now get everything we want. Our goal for this problem is to find how fast the balloon is rising. So how fast the balloon is rising. This term, how fast, this means rate of change. And we know that this is the height. So what we're really looking for is dH dt. So what we need to do then is here I've got theta and I've got height. We need to take the derivative of both sides with respect to t. So we're going to get that dH dt, we're going to get that 500. The derivative of tangent is secant squared theta times d theta dt, because we have to use the chain rule because we're using implicit differentiation, is equal to the derivative of h is 1 times dH dt. This was my goal, so now all I need to do is plug in numbers and figure out what the answer is. So dH dt is equal to 500 secant squared, and theta at the moment we want is pi over 4, times d theta dt, we know from the problem, is 0.14. Now it just requires some calculations. dH dt is equal to 500 secant squared. So secant of pi over 4 is 2 divided by root 2 times 0.14. dH dt is 500 times 4 over 2 times 0.14. So this is 500 times 2 times 0.14, 1,000, 0.14, and you're going to get 140. So dH dt is equal to 140. But 140 what? Well, our problem was in feet, so we're going that it increases at 140 feet per minute. Because we know that d theta dt is in radians per minute. So now we just need to write our answer in a complete sentence. When the angle is theta is equal to pi over 4, and when I mean angle, the angle between the rangefinder and the balloon is rising at a rate of 140 feet per minute. And this is your complete answer.